what do you see as being the key components of this modern data architecture that would support AI readiness?
Yeah, To a Fault and Sesame's sponsored some 50 projects. We always have them start building up, whether it's a new data source, their first instrumentation, or exploiting an existing data source in a legacy architecture. There are 3 steps everyone should go through. So the first is the connectivity and the adaptation to the data. Most manufacturing environments are what we would call heterogeneous, meaning it's a mix of data sources. And sometimes there are like data sources with unlike methods of communication. I'd say many times. I have 2 machines that do similar things, and I would love to be able to train a machine learning algorithm to predict something on one machine, and then take that prediction and be able to run that trained model against a similar machine that does similar things. But the first problem occurs if those 2 machines speak 2 different languages. So we could talk about that being a protocol problem, but there isn't actually value in the connectivity to the machine. It's a necessary step. But just talking raw to 2 different machines is meaningless unless I can translate them into a common language. You might call it a unified namespace if you'd like. But how do I ensure that the 2 like machines are emitting like data? That's kind of problem number 1, is can I translate data sources to a common namespace? Also in the namespace concept, and I think maybe some of the more mature implementations include this, is the notion that the points of data within the machine should not be a flat list. The machine in operation has relationships in the data that I can express with structure. So if I do that with a JSON payload, it looks like a nested JSON payload. It implies relationship. Those are hierarchical relationships. This point of data is composed of these points of data, or this object is made up of these properties. And that's a really good start, is not losing those relationships. Those kinds of like nested relationships facilitate like roll-ups and aggregation. They also facilitate good programming principles like composition. So this machine is made up of subpoints of data, and some of those compositions may exist in other machines. So that's a really good first step that we try to encourage our projects to think through, is not just what are the points of the data in this machine, but are there implicit or explicit relationships in the data that you don't want to lose? But what you can really begin to think about there, and it bleeds into kind of step 3, is the fact that relationships between data are not strictly hierarchical. A point of data may own or be hierarchically related to another point of data, but it may also be orthogonally, non-hierarchically related to another point of data. There are interactions in a machine that I can't necessarily capture in a nested structure. Things like energy consumption may be related to the machine's speed or the machine's quality, but it's not necessarily an ownership relationship where the quality of the machine is owned by the energy output of the machine. So I need a mechanism that allows me to understand the context of a given machine and the interrelationships of its data. And it's important to begin to introduce this concept, whether I exploit it at the individual data source level or not, because I need to zoom out and I need to understand that asset, that data source, in relationship to other data sources in my operation. Easy to understand hierarchical one is that one machine's output feeds the input of another machine. That can be expressed fairly linearly. Often we organize in like an ISA 95 structure, which is hierarchical in nature. But that machine also has these orthogonal, like shooting out non-hierarchically relationships. That machine has an orthogonal relationship to an operator. That machine has an orthogonal relationship to a material supplier. It has an orthogonal relationship to the ambient environmental conditions. things that aren't part of the machine, but are at points of time related to the machine, are part of the context of the machine, or more broadly, the data source. One of the kind of more important insights that some of our mature mature manufacturer projects are exploring is the relationship between the machine as a data source and the job as a data source. The job is a structure that can be expressed in like a JSON payload, but it has an interaction with the machine such that the limits of the machine, the operational settings of the machine, are different than maybe its physical boundaries based on what job it's performing, based on what it is it's producing. So I have to build up from normalizing the data, standardizing a namespace, if you will, but then expanding my thinking beyond the namespace of the data source to the full graph of relationships, the context that the data source exists in at a point in time.